Hi, in this video I'll be showing you the configuration management framework Hydra and how it can help you manage and configure your machine learning applications very easily in Python. Hydra is an open source project by Facebook Research that can help you make more structured machine learning applications in Python. Hydra specifically aims to structure projects, ease the process of configuring complex applications, and ease the process of monitoring your applications. You might often find yourself configuring scripts through the command line with arguments in Python programs using packages such as the argument parser or argparse. With Hydra, you can structure the configuration in configuration files, structure configuration files, and then also make overrides using the command line. I strongly recommend you to check out the GitHub page. It has some really nice information. I also strongly recommend you to go ahead and the website. They have a lot of really good documentation on there with tutorials and also just some general introduction to the Hydra framework. In general, overall, I just strongly recommend you to using a framework such as Hydra when you're working with machine learning problems, since it can help you tons with saving all your configurations and the model's performance. It basically can help you keep track of all your experiments. The example that I will show you today is image classification on the MNIST dataset. The MNIST dataset is a large database of handwritten digits that is quite commonly used for various image processing systems, or at least the evaluation of them, and often also you'll be seeing them in tutorials where different methods are introduced. It's a really cool dataset, and I suggest you to play around with it if you have never tried it before. The code itself is not the focus of this video, but I'll still give you a quick walkthrough of the code to put the configurations I'll be showing you into context. As you see, this project consists of multiple Python files. Let me just unfold these. We have the main file, which I'm showing you right now, and then we also have two Python packages. We have the core module and models. The registry Python file implements a base class for factories, which I'll be using for my model factory. The timing Python file implements a function that I've created to measure the computational time of a method invocation, which I use to measure the time of the training of each method and the scoring of each method. The model factory is used to register and build the models. Then we have the k-nearest neighbor classifier, where I've used the implementation from scikit-learn. Finally, we have the random forest classifier, where we yet again have used the implementation from scikit-learn. Before we head into Hydra, I'll just quickly show an example using the argparse module from the Python standard library. In the top of the main file, we have all the imports. So I'll be using scikit-learn. I'll be using my own utility functions. Then I will also be using argparse, the argument parser, and logging. So the first thing you see is a class called model_config. It only has two attributes. It has type, which is a string, and k, which is an integer. So I've just set up this class in order to make a small configuration of a model, which you'll see later on what I mean by this. Then I instantiate a logger, which I'll be using to log different events. So if the main file is being ran, then it will go into here and execute all the code. The first thing that happens is basically that we add some arguments that we might need to use for the method. So there's the k, then there's the type, there's a string for the dataset, so the default is the MNIST dataset, and then there's the train test split, where the default is 0.9. I then go ahead and fetch the dataset from OpenML. I then go ahead and split the dataset into xtrain and xtest, where 90% of the data instances is in xtrain. I then go ahead and create the model config, only based on the type and the k. I then create the model using my model factory, and then I call the model.fit on the xtrain and the ytrain, which is the data instances and the labels. The time func is only used just to measure the time it takes for the method to run. And then I go ahead and score it and print out the accuracy. So let's just test it. It works. As you see, the code successfully completed. What we can now do is go ahead and change the arguments by providing it from the command line interface. So what I'm going to do now is call the main file from the command line and then set the type parameter or the type argument to random forest. Okay, and it's done. So we can see, okay, it took quite a bit more time fitting the model and was quite a bit faster scoring the model. So that's how you might do. You might also want to go ahead and put, for example, some of the train test splits, put it to 0.70, go ahead and maybe write the K to 4, something like that. And as you might see, this is actually quite smart since we can configure our methods and applications from the command line and actually make it quite flexible. However, there's an even more smart way of configuring our application, and that is using Hydra. So I'll be going into that now. I will now set up the application to be a Hydra application. So first of all, I'll define a function call. Let's just call it my Hydra app. And it's not really going to do a lot of things in here, but I'll just take all of this code up to, let's say, up to here. Put it in. I'm going to remove all this argument pass. I'm not going to use that anymore, so I'll just go ahead and call my Hydra app. Just like that. Gonna base. Okay, so now we're one step closer. What I then is going to have to do is put in the decorator for Hydra. So hydra.main, set the version base to none. Then I'm going to set the version base to none. Then I'm going to set the config path to conf. And then I'm going to head and say that my config name is config. Okay, so it complains here because I haven't imported Hydra yet. So I'm going to go ahead and do that instead of the... So now it's okay with it. So what I've basically stated up here is that you should go ahead and look in the conf folder for a file called config. So let's go ahead and set up my configuration folder. I'm just going to call it conf and then add a new file. So it's going to be called config.yaml. First thing is that the config files are hierarchical, so I can put in a key that's named model. Say I have a type, let's put in KNN, and then I have the model parameter K. Let's put in 10. Then I also have some settings related to data. I have the dataset name, which is MNIST 784. And then I also have the train test split, which is 0.90. Then I'm gonna get a configuration injected into my method and then return none. As you see down here, I'm not providing any input into my method, but that's being taken care of by the decorator. So instead of using the args structure, I'm now going to go ahead and use my config. I know that I have something related to my data and then dataset name. Then I have yet again config.data and the trace relation split, and then config.model type and config.model.k. And that should be it. So it's really easy. And just in order to show you how it actually is perceived from the program, I'm just gonna lock the data structure itself of the configuration that's being injected into this method. So it's omega conf that I have to use for this. Import it. So from OmegaConf, import Omega that to YAML of the config. And that's it. That's it. So I can just run it now. Okay, as you see now, we got the input with the model being having the type KNN, K10, and then data, the MNIST 784, and printer split 0.9, exactly as we expected. It then also prints out the logging, which I find is really nice. We can just configure it to whatever we want, but I really like it when I'm just debugging my code, just having it print out into the terminal. Okay, so the model is now done training on the MNIST dataset and classifying on it yet again, and we see that the accuracy is 0.97. And we can just remove this class model config up here. We don't really have to use that anymore. And then I'll just remove this definition of CFG and then instead directly pass in the model property of the configuration that we have injected into the method. That was the most basic elements of Hydra. However, instead of defining our configurations in the YAML file, we can also go ahead and create what is called structured configuration files. Structured configuration files are defined in Python files using data classes, and this has some really nice pros to it. For example, there's runtime type checking, ensuring that we provide the correct types to our methods, and then there's also the static type checking. For example, when we're using PyCharm, which can help us check which kind of types that we are passing around in the configuration. Now we will create a structured configuration file. In order to do that, we'll just go out and add a new Python file, call it structured-config.py. First, I'll just set up my imports. So from Hydra, I will need the config store, and from data classes, I will need both data class and field. Okay, so now I'll set up all the subcomponents for my configuration. First, I'll set up the model configuration, which contains the type and also the model parameter k. The type is of type string, and I'll just set the default value to KNN. Regarding the k, it's a type integer, and I'll set the default value to 10. Next, I'm going to add in the configuration for the data specifics. First, it will have an attribute which was called dataset name with type string and a default value MNIST 784. Then we have the train test split. That's of type float, and I'll set the default value to 0.9. Then what we can do is basically assemble these two into a hierarchical configuration. So I'll create a class called config, and then I'll instantiate attribute called model and one called data of the two types defined above, and then set it to have the default values. And then what I will then do is basically have the config class injected into my method later on, and then I'll basically be able to access directly the model and the data and the default configurations that we have defined in here. After we have set up this last config class, then I'll just get the config store instance and just add this new configuration into the config store in order to me being able to get it from the method in the main file. Now I just need to make a minor edit to my decorator up here. I just have to remove the path since I named the configuration config in the structured config file. And then the final thing I can do is define which type the configuration is, and I'll just have to import it from my conf folder and from the structured config file, and then I can just set the type down here in my function, my Hydra app. And that's all we have to do in order to use the structured config file and I'll just run the script once again in order to show that it still works. Okay, and it's done. So as you see up here, I now have a folder called outputs. And that's one of the cool things of Hydra. It creates an output folder and puts in, it basically structures it. So we have, first of all, have the date up here, and then we have the time at which the code was run. And within this one, I have the main.log file. And that's basically all my logging. It stores in here. I can see which file it was that led to the logging and the content of it. I can also click on the .hydra folder up here and see how was my configuration when I ran this one. So let's just see these two. It's exactly the same. I did nothing interesting. And then I can also see the Hydra stuff directly and see if I have overwritten any variables within my config. So let's say that I want to overwrite my configuration up there. Then I can basically just go ahead and write ++, and then say model.type equals random forest. And now we have one of the really cool things that I really like about Hydra. That's I can launch multiple jobs at once. So let's say that I want the random forest and then the KNN. That's all I have to do. Put a comma, press enter. Oh, I just forgot that I have to put in the multi-run flag. So let's just do that. So what it will do now is first run the method using the random forest input, as you see right here in the terminal. And then once that's done, it will launch the second run and should hopefully print out that it's using the KNN method. As you see in the terminal, it's now executing the script with the KNN model. So that's really nice. We can now set up multiple configurations and have the same script execute multiple times using all the different configurations. And then it will also report its outputs in a structured manner, which is really nice. And I will show you how this multi-run works, this multi-run logging. So we have the log for both runs. We have the KNN. We see the override right here as the model type is KNN. And for the first one, we have that the override is random forest. And then we also see in the config file that the type is actually the random forest. I really hope you enjoyed this video. If you'd like to see more videos like this in the future from me, please like and subscribe. And if you have any questions, please let me know in the comments.